30 amp breaker is not correct for a compressor that has a maximum of 25 amps of protection. The breaker should be sized to protect the compressor from overcurrent, which means it should be rated for less than the maximum current that the compressor can draw. In this case, a 25 amp breaker would be the correct size. The National Electrical Code, often referred to as the NEC, requires that branch circuit breakers be sized to protect the conductors and equipment on the circuit. The NEC also requires that the breaker rating be based on the ampacity of the conductors, which is the maximum amount of current that the conductors can safely carry. In this case, the conductors that supply the compressor should be rated for at least 25 amps. If a breaker that is rated for more than the ampacity of the conductors is installed, it may not trip when the conductors are overloaded, which could lead to a fire. Therefore, it is important to size the breaker correctly to protect both the conductors and the equipment on the circuit. To elaborate, let's delve deeper into the specifics of overcurrent protection, ampacity, and the relevant sections of the National Electrical Code. Overcurrent protection is a fundamental principle in electrical safety. It is designed to safeguard electrical circuits and equipment from excessive current flow, which can result in overheating, damage to components, and even fire hazards. Circuit breakers and fuses are the primary devices used to provide overcurrent protection. They are designed to interrupt the flow of current when it exceeds a predetermined level. The ampacity of a conductor, as defined by the National Electrical Code, is the maximum current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. This rating is influenced by factors such as the conductor's material, size, insulation type, and the ambient temperature in which it is installed. The National Electrical Code provides tables and guidelines for determining the appropriate ampacity of conductors based on these factors. When selecting a circuit breaker for an air conditioning compressor, it is crucial to consider the compressor's nameplate information. The nameplate typically specifies the minimum circuit ampacity, MCR, and the maximum overcurrent protection, MOP. The minimum circuit ampacity indicates the minimum size conductor required to supply the compressor, while the maximum overcurrent protection specifies the maximum size circuit breaker or fuse that can be used to protect the circuit. The purpose of limiting the size of the overcurrent protection device is to prevent damage to the compressor in the event of a fault or overload. If the breaker is too large, it may not trip quickly enough to protect the compressor from damage. The National Electrical Code contains several articles that address overcurrent protection and conductor sizing. Article 240 covers overcurrent protection in general, while Article 310 provides guidelines for conductor ampacity. These articles provide detailed requirements for selecting and installing overcurrent protection devices and conductors to ensure electrical safety. In the situation described, where the air conditioning compressor has a maximum overcurrent protection rating of 25 amps, installing a 30 amp breaker is a violation of the National Electrical Code. The 30 amp breaker exceeds the maximum allowable overcurrent protection for the compressor and could potentially lead to damage or fire hazards. The correct approach would be to replace the 30 amp breaker with a 25 amp breaker or a smaller size if permitted by the compressor's nameplate in the National Electrical Code. It is also essential to verify that the conductors supplying the compressor are adequately sized for the 25 amp breaker. The conductor ampacity must be equal to or greater than the breaker rating to ensure that the conductors can safely carry the current without overheating. In addition to the National Electrical Code requirements, local electrical codes and regulations may also apply. It is crucial to consult with a qualified electrician or electrical inspector to ensure that the electrical installation complies with all applicable codes and regulations. Furthermore, it is vital to understand the difference between different types of overcurrent protection devices. Circuit breakers are electromechanical devices that trip and interrupt the circuit when an overcurrent condition is detected. Fuses, on the other hand, are one-time devices that melt and break the circuit when an overcurrent occurs. Circuit breakers can be reset after they trip, while fuses must be replaced. The choice between circuit breakers and fuses depends on the specific application and the desired level of protection. Some applications may require the use of specific types of circuit breakers, such as inverse time breakers, which trip faster as the overcurrent increases. These types of breakers are often used to protect motors and other equipment that can withstand short-term overloads. In summary, selecting the correct size circuit breaker for an air conditioning compressor is essential for electrical safety and equipment protection. The breaker size should be based on the compressor's nameplate information, the conductor ampacity, and the requirements of the National Electrical Code and local electrical codes. Installing a breaker that is too large can lead to damage, fire hazards, and code violations. To reiterate, you absolutely must adhere to the manufacturer's specifications. They are there for a reason. Disregarding them can be catastrophic. The maximum overcurrent protection MOP is not just a suggestion, it is a hard limit. Let's consider an example to illustrate the importance of correct breaker sizing. Suppose an air conditioning compressor has a nameplate rating of 20 amps minimum circuit capacity and 25 amps maximum overcurrent protection. The conductors supplying the compressor are rated for 30 amps. In this case, a 25 amp breaker would be the appropriate size. If a 30 amp breaker were installed, it would not provide adequate protection for the compressor. If the compressor experienced an overload and drew 27 amps, the 30 amp breaker might not trip, and the compressor could be damaged. However, if a 25 amp breaker were installed, it would trip quickly and protect the compressor from damage. In addition to protecting the compressor, the correct size breaker also protects the conductors. If the conductors were overloaded, they could overheat and potentially cause a fire. The breaker is designed to trip before the conductors reach their maximum temperature rating. Therefore, it is essential to ensure that the breaker is sized correctly to protect both the equipment and the conductors. It is also important to consider the ambient temperature when selecting a breaker. The ampacity of a breaker can be affected by temperature. If the breaker is installed in a hot environment, its ampacity may be reduced. In such cases, it may be necessary to use a larger breaker to compensate for the temperature derating. The National Electrical Code provides guidelines for derating breakers based on ambient temperature. Furthermore, it is crucial to ensure that the breaker is properly installed and maintained. Breakers should be installed in a dry, clean environment and should be regularly inspected for signs of damage or wear. If a breaker is found to be defective, it should be replaced immediately. It is also essential to test breakers periodically to ensure that they are tripping correctly. There are several ways to test breakers, including using a circuit breaker tester or by simulating an overcurrent condition. If a breaker fails to trip during testing, it should be replaced. The National Electrical Code also addresses the use of ground fault circuit interrupters, GFCIs, for certain applications. Ground fault circuit interrupters are designed to protect people from electric shock. They trip when they detect a ground fault, which is a condition where current is flowing through an unintended path to ground. Ground fault circuit interrupters are typically required for outlets in bathrooms, kitchens, and outdoor areas. While ground fault circuit interrupters provide valuable protection against electric shock, they do not provide overcurrent protection. Therefore, it is still necessary to install the correct size breaker to protect the equipment and conductors. The relationship between conductor sizing and breaker selection cannot be overstated. Conductors must be sized to handle the anticipated load, and the breaker must be sized to protect the conductors. This is a fundamental principle of electrical safety. The selection of conductors is based on several factors, including the ampacity of the load, the ambient temperature, and the type of insulation. The National Electrical Code provides tables and guidelines for selecting the appropriate conductor size for various applications. In summary, the process of selecting the correct breaker size involves several steps. Firstly, determine the minimum circuit ampacity, MCA, and maximum overcurrent protection, MOP, ratings from the equipment nameplate. Secondly, select conductors with an ampacity equal to or greater than the MCA. Thirdly, choose a breaker with a rating equal to or less than the MOP. Fourthly, consider any applicable temperature derating factors. Fifthly, ensure that the breaker is properly installed and maintained. By following these steps, you can ensure that the electrical system is safe and reliable. Remember, when in doubt, consult with a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. A qualified electrician has the knowledge and experience to ensure that electrical installations are safe and code compliant. They can also help you troubleshoot electrical problems and provide expert advice. Do not attempt to perform electrical work yourself unless you are properly trained and qualified. Electrical work should only be performed by licensed electricians. If you are not a licensed electrician, you should always hire a professional to perform electrical work for you. This will help to ensure that the work is done safely and correctly. It will also help to protect you from liability in case of an accident. Always prioritize safety when working with electricity. Electricity is a powerful force that can be dangerous if not handled properly. Take the necessary precautions to protect yourself and others from electric shock and fire hazards.